And we are live. Welcome everyone to SQL Friday. This is episode 25, and our star for today is Kathi Kellenberger, who stood up middle of the night o'clock to make a presentation for us. So we're all very grateful to have you here, Kathi.
Thank you.
Welcome. The topic is modern T-SQL, and I will let you tell us all about it. The stage is all yours.
Okay, let's see if I can figure out how to share on Teams. So back in 2005, I started presenting on new features of T-SQL. That was when I was first getting started presenting, and it just seemed like a really good topic. And it was another way to help me learn the new things that were coming out. And then eventually around 2012, there were so many new functions in this group of features called windowing functions that I ended up starting an entirely new presentation just on that group of functions. And then eventually that turned to 2 presentations, and eventually it turned to a Pluralsight course and a book. And I still present on to this day, and I'm always amazed when I go and give a presentation that I don't, that the people in the room haven't heard of windowing functions and haven't heard of a lot of things that were added to T-SQL over the years. And I kind of get that, because when you're working, sometimes you just like to use the tools you have. You've got to solve this problem and you know a way to do it. And sometimes you kind of forget that maybe you should pay attention to new things that could help you solve the problem that might perform better or might be easier. So that's what I'm going to kind of talk about today, some of the new things that have been around for a while that can solve some particular problems. And I've got some specific problems or use cases to show you. I don't know if they're quite use cases, but some interesting problems that I've ran into over the years that there's old ways to do it. And starting around really 2005, 2012, and even 2017 and 19, there are a lot of new things in SQL Server that can really help you write code or make things perform better. So I'm Kathi Kellenberger, and I'm the editor of Simple Talk at Redgate. I'm the co-leader of the past virtual group, and my slides are advancing on their own. That's odd. And I am an instructor at an organization in the St. Louis area called Launch Code that helps lift people out of poverty and gives them a chance in tech jobs, people that really want to work in tech but haven't been able to afford going to university or just for whatever reason have had a hard time. So I'm a teacher in that program. And I'm also a lifelong learner and teacher, and that's the most important thing you need to know about me. So today I've got several problems that I want to go over. And some of these are things that I worked on back in around 2008, 2009, and I actually worked on them for Redgate, even though I didn't work for Redgate at the time. At the time, it was for Simple Talk articles. And so some of these are the first 3. Let's see, the first 3 involve those problems, and then the 4th one is a well-known thing that is known you have to do in computing, for example, finding dates that there were not sales, things like that. So it's just kind of interesting. And then some other things actually I should have made that 2017 and 2019, some things called intelligent query processing. I'm going to show a few of those that can make your code run faster without you making any changes. So let's get started. The first one, well, I'm not quite to the first one. I forgot about this slide. Again, a lot of times we're stuck doing what we know works. We can figure out a problem, and a lot of times it comes from our background. If you started as a developer like I did, and then come into become database focused, like a database developer or a DBA, you may have learned how to do things a certain way, and that might lend you to writing cursors or loops to do the programming. For example, when I first became a DBA, I had all these stored procedures that did work at night, and there was one that had a cursor that looped through a couple thousand rows and made changes that based on if person's name changed or their salary changed or anything changed about them, and it looked through every single person, looking through those, and it took about 10 minutes to run. And it was really easy to do that in a set-based manner to get it to run in just a few seconds. So occasionally a cursor loop is going to be the right answer. I never throw anything out of my toolbox. Everything in my toolbox is important, but I want to make sure that I use the right tool for the job. And keeping up with the new T-SQL features will help you keep adding good tools in your toolbox, and maybe some of those old ones you may not need it nearly as often. So some of the things that people have done in the past, again, cursors and loops, sometimes self-joins, and really before 2012, we didn't have a lot of options on some of these really, really tricky problems. Scalar UDFs I've seen so often, and those are usually really red flags for me. And sometimes I've seen them nested, and sometimes it's just very easy to take those out or refactor those. And luckily in 2019, there's a way that you can not have to do that for some of them. And I'll talk about that towards the end of the presentation. All right, the first one is my favorite, the stock market problem. And the reason I usually start all of my T-SQL window function sessions with the stock market problem. The reason I like this one is that I was working as a consultant on a SSIS project a few years ago, probably about 7 years ago now. And the DBA there came to me and said, every night I take this data from the stock market and I collect it, put it into a SQL server, and I want to compare the close price from one day to the next. So I helped him write that query. And then a couple months later, a junior developer, I was working at Pragmatic Works at the time, and a junior developer that I was mentoring said, "Hey, Kathy, I've been pulling this stock market data every night, and can you help me figure out how to close price from one day to the next?" Now, you may think I'm making this up, but this is absolutely true. This is how it happened. So the stock market problem has these symbols for each company. I have a bunch of made-up symbols, and then there's a date, and then there's a price that it closed. Now there's also an open price in the original data. However, the close price from one day does not necessarily equal the open price of the next day. Something could happen overnight to change that. So what I want to do is grab the price from the previous day and then subtract to find out what the change was. And I want to make sure that I don't compare Z1 to Z2. I've got to be really careful there. So let me just show you the stock market problem. So hopefully you can see my SSMS now, that I opened the right thing. So I have all this made up data. It looks like I've got almost 700,000 rows that looks something like this. And if I look at just one particular one, you can see that we've got these trade dates that are, starting in 2017, a few years. So how do I solve this problem? So the first thing I might think of is that, I need to do a self-join. I need to join the table on itself and look for a previous row. I'm going to join on the symbol, and I'm going to do this this where the trade date of one is greater than the trade date of the other. So when I run this, it does run. However, it doesn't give me the right result, and it's still running. I'm going to kill it. and it ends up being basically not really a Cartesian product, but similar to that, where I'm just getting the same close price over and over and over, and I have over almost 900,000 rows here, so obviously that is not correct. But that was my first thought on how to solve this problem. Another way that might make sense is to create a temp table to throw the data in there and run a cursor to do updates. I'm not going to run this during the demo. So basically, I've created a little table and I've just inserted the data, and then I just go through it and keep track of the previous day and keep track of when it switches. Now, back in probably 2010 or 11, this would be the way I would probably solve this problem. I let it run 2 minutes before I came on today, and it did work, but I've only processed 2,664 rows, not the entire data set in 2 minutes. So while it does work, it is not really correct. So if I had to do a solution like this back in the old days, what I might do is just use a cursor solution, but don't repopulate the whole table, just repopulate the previous day, which wouldn't be quite so bad. And if it was a process that ran, at night, maybe nobody would care about that. Maybe it'd be fine. So another thing that I might try to do is use the apply operator, or the outer applies. So inside here, I have a subquery where I'm just accepting the top one, which solves that problem that I had in the very first example where I tried to solve this, but it was bringing back, matching everything up, where this way I've got the same joining criteria, but I'm only bringing back one. I'm only going to run this on four symbols instead of the whole thing, because it does take a long time to run, really long time to run, but it will work. So it did work. It took 2 seconds to run on just a handful of symbols. When I tried it the other day, it took 40 seconds to run on the entire thing. So I'm not going to do that. So how do I solve this problem? Well, hopefully some of you have heard of the function called lag. Lag is my favorite function. Some people have a favorite band or a favorite movie. I have a favorite function, and it's called lag. So what lag does is let you grab something from a previous row in the data. So here I'm only joining, I'm not doing I'm only looking at stock history one time. And it's still running. There it goes. It took 5 seconds to process almost 700,000 rows, and that included populating this grid, which does take some time when you've got that much data. If I had just saved these results somewhere, it probably would have been even faster. So I've got this function called lag, where I can look back at the previous row. It's got this thing called an over clause that determines what I'm looking at. I want to make sure that I'm only looking in the current ticker symbol, and I'm ordering by the trade date to make sure things are lined up. So here I'm showing you the previous price, and here I'm using that formula again to do the subtraction. So this is one of those windowing functions that I talked about at the beginning that have been like most of what I presented on in the last how many years, since the last 8 years. So I want to show you a little bit, talk a little bit more about that. I just showed you that over clause, but this is something new with 2012. I have been in presentations, not as much recently, where people will come up to me and say, we've been trying to solve a problem that could have been solved with lag for years, and I'm going to go, to my manager on Monday and say, we've got to upgrade to 2012. So now that it's 2020, I don't hear that story about I'm going to tell my manager upgrade. I think a lot of folks have upgraded to that or past it. I still get people coming up to me and saying, wow, we can really use this. I had no idea. You know, I'm just so glad that I can go to work on Monday and solve this problem that we've had for years. So it's been a really good thing to talk about because people just haven't heard about it. And I do have some resources at the end if you want to get more information about these and some of the other ones. Any questions?
No questions so far.
No question. I will move on. All right. The subscription problem. So some of you may remember these things in the photo. I still get one, Time magazine in the US. My husband gets a couple of them. These are called subscriptions, like magazine subscriptions. So this problem was part of the thing at Simple Talk way before I worked for Redgate, 10 years before practically, called Speed Freakery Contest. And with PH, Speed Freakery. And this is something that Phil Factor came up with, where he came up with these really difficult problems to solve, and they had a contest to see who could come up with the code that would run the fastest. The problem is the code was so difficult to understand, and there were probably maybe four, don't remember exactly, maybe four of these contests. So what ended up happening is that Redgate approached me and said, you are good at explaining things to people. Can you figure this code out and write an article to explain it? So I did that, and those articles are still out there. But what ended up happening in 2012, when I started looking at windowing functions and some of the other new functions that were available, I said, wow, maybe these could be solved even easier. So I ended up revisiting some of the problems and writing the windowing function solution instead of what I came up with. So in some of these, I explained, and it was pretty difficult, these guru solutions, and then I came up with the Aunt Kathy solution that would run almost as fast, but then now with windowing functions in 2012, and actually another function I'm going to talk about, they were able to run really fast, but yet also be easy to do. I'm hoping this is just not easy in my mind. I hope that you will agree that this is easy to solve with the newer modern features. So this is what the data looks like. There's a registration ID, date joined, and date left. So basically, you sign up for a subscription. It might be a magazine subscription or something else, and you can get it for so long and then decide you're no longer going to get it. So how many current subscriptions are there? If you look at, you can count up the previous subscriptions, add the new ones, subtract the ones that have left, and then you end up getting something like this. So what the original solution did, actually I've got my solution where I've got the end of the month, but the original solution, what they did with these dates is normalize them or standardize them on the first of the month. So we don't care about partial months in this problem. We just care about the actual month. So that's what they did to standardize them. So let's take a look at how to solve that. Did I close? No, I didn't. I'm like, oh my gosh, I hope I didn't close that. All right, the subscription problem. And we're using, I've generated 1 million rows. The original data had 10,000 rows. And just by looking at this, I remember that somehow that there was a data set that got lost. No one's complained, but I noticed the original article had the data set got lost. I might need to go out and fix that. But this is what the data looks like. I have generated 1 million rows instead of just 10,000, because one thing that I've noticed, things that took a long time to run back in 2008 and 2009 now run fast because the hardware is so much better. That's one thing. There's things that I'm like, why is this running so fast when back in the day it took 2 minutes? You know, that's part of the reason. So 1,000,000 rows. One thing that I can do is look at this kind of as I can just take that data where it's all in one table, and I can just make like 2 views or 2 queries out of it. I can just separate that to make this easier to solve. So here I've got the new registrations, and I've also got the unsubscribes, if that's a word, the people that have left. Okay, so if I can join those together and kind of do a running total, I have my problem solved. So here's like one of the worst ways to do it. I start, not because of the common table expression. I know a lot of people hate those. I like them. Another tool in my toolbox, I like to use the common table expression, but then if there is an issue with performance, then I'm going to back up and look at another way to do something. I like it with this because I can take that first query that I wrote, and I'm only looking at 15 years of data here, and I do have indexes on the dates, so that's, you know, check, make sure that was fine. Take the people joined and the people left, and the reason I'm only not using the whole data set is because this will take forever to run, and I might be able to get it to run, you know, where it makes sense. Let me collect the whole thing and run it while I'm talking. So then I have another CTE where I'm joining the data together, and the way that this is how the original date was treated in the speed freakery problem, where they basically broke the data and put it back together. It's still going. And then we've got this running total problem, where some people call it a triangular join. I'm adding the people in, subtracting the people left, and I'm looking at where one date is less than or equal to the other date. Did it work? Looks like it worked. Looks like it got done. Took 33 seconds. And it does look like it worked correctly. So that's one way to do a running total. Not a great way to do it, though, because see how long it took. In a course in 2009, what FillFactor did was provide a cursor solution for each one of these, just to make sure that all the people participating had something to check against, make sure that their thing was correct. And this thing used to take a really long time to run, and this is the one that now runs fast. So isn't that crazy? 1 second for the cursor solution, where the self-join took 30 seconds, and I didn't even check all the data. And it wasn't because of the where clause, because it would take even longer if I didn't have that in there, because I do have it indexed properly. So here's the modern solution. This is a solution that I could come up with starting in 2012. So I've got my new subscriptions, my cancellations. I am going to join those, and I'm going to do something I like to call, what do I call this? It's a accumulating aggregate. So I've got this sum over. This is another window function, a window aggregate. But in this case, I've got an order by, how things are lined up, and I have this thing called a frame. I could spend 20 minutes talking about the frame here. So if you haven't seen this before, I suggest you take a look at the resources that I have on the last side, and I'll send that in to the organizers so they have it. So let's run this. This is actually easy, much easier once you understand windowing functions. If you haven't seen them before, it might be a little bit more tricky. But there, it ran in less than a second, and it does have the correct answer. So any questions before I move on to the next thing?
There was the mute button. No questions so far.
Okay, sorry. I will continue. Okay, so again, running totals, new with SQL Server 2012. In 2005, you could do a sum over. I'm going to talk a little bit about that in a later demo, which would allow you to add different grouping levels of aggregations. But in 2012, you could add this order by, and this is really important nowadays because we're seeing you can do things like doing a running averages. So like where I live right now, we've got like a 15% positivity rate when we look at the running average over the last week, which is really scary. So this type of calculation is kind of on a lot of people have heard of it where maybe have never thought about something like that before. All right, the next one, the end of the month problem. This is just kind of a subset of the previous one. If you, let's see, do I have another? Nope. If you have a calculation that's looking for the beginning of the month, looking for the end of the month, something like that, you might do something like tear the date apart, put it back together. So now I'm forgetting whether it was 2012. I'm forgetting which version of SQL Server gave us this function called EO month. And
I think that was 2012 as well. There was
I think it was 2012
features in there.
Yeah, it's like, so there were a bunch of functions I like to call the easy functions. Like there was one called IIF. I don't know if many folks use it, but it's kind of like a real simple way to do a case. But you know, if you've been doing case forever, you're going to stick with case. There was the split function. I remember seeing a lot of people writing articles saying the split function did not perform as well as if you had a user-defined function or something that split, you know, a comma delimited list out. But if it was like 10 rows, let's say you've got something from reporting services coming over, multiple values separated by commas, that split function is really, really, really easy. I probably should add that to this. Let's see, EO month. So one of the things that I changed about the subscription problem was that I use this EO month function instead of tearing the date apart and putting it back together. So the EO month gives you the last day of the month. And since all I need to do is standardize, so I've got the same date each month. So in February, I want to make sure that if it's a leap year, all the Februaries are February 29th, right? I need to make sure if it's, you know, March, it's all March 31st. Hopefully I got that right. So I wondered if maybe using that EO month function did not perform as well as just tearing the date apart and putting it together. You know, I really wondered about that because when these easy functions came out, a lot of folks, like I said, they did tests on a lot of these just to try to find out if they performed worse, if they performed better, you know, what was really going on with these. So I'm like, well, for one thing, it makes it a lot easier if you want this, if you need the end of the month or you need to just standardize the months. So this is, you know, how I would have to write it. There's also even a format function in 2012. You know, you could, I guess you can't really use that to do it, but there, I just remember, you know, for years, like before we had some of these functions, people just tearing dates apart, putting back together, and you've got casting and just really difficult and messy. And, you know, I don't know that this performs that well. Who knows? So to test this, I wanted to use a bigger table than was available in AdventureWorks. And I like doing examples and demos with Adam Mechanics Thinking Big Adventure tables. And you may know him because he also is the author of SP Who is Active. And you can download these scripts from him and create a pretty big table. One of them is over 31 million rows, but sometimes that's too much for demos. So I often like to make copies of that table and just make them smaller. So in this case, I have one I call small transaction history, which is just 25% of Adam's table. So I don't want to populate the grid, so I'm just going to throw the results in a temp table and go ahead and run this from this small transaction history table just to see, you know, how long it takes. Hopefully it doesn't take too long. There it goes. It took 6 seconds, and that wasn't too bad. And I'm just going to go ahead and select from that just to make sure that it did work. It does look right. I'm going to go ahead and do this just to clear the cache out so I'm not cheating. And I'm going to do the same thing, but this time I'm going to use the EO month function. Hopefully I'm saying that right. Who knows what this function is supposed to, how you pronounce it. I just call it EO month. I don't know. So hopefully that just took 2 seconds. I can't remember exactly what the other one was, but I know it was quite a bit longer. And it also did work. But what if I tried it on 30 million rows? Would it work well on that? This is the greater than 31 million rows. And it's still running. Hopefully it will end soon. And took 14 seconds. So it's, you know, the more data you have, the longer it's going to take. But it still was pretty quick. And that was, you know, absolutely no chance of caching since that was fresh. That was not, we didn't touch that table before. So how long did this one take? I can't remember, but it did take quite a bit longer. So any questions before I move on?
No questions.
Okay. Well, I've got room built in for questions. So if I get done early, because I've only got 2 more things to talk about. All right. So I had to talk about the islands and gaps problem because I just love this photo. This is one I actually took myself when I took my family to Hawaii. And for all of you Star Trek fans out there, my husband and I renewed our vows. I don't know if that's something that's only a US thing, but like you have a big anniversary, our 40th anniversary. I wanted to renew our vows on a black sand beach, and I wanted to use the vows from Dax and Worf. So some of you Star Trek fans will know what you are talking about. They did not attack us. My family did not attack us with the, I don't know how to say, the batleth or whatever, with the weapons after the ceremony, but I just love the vows that they use. So that's what we did. So one of my favorite things. So the islands and gaps problem, this is something that is a very popular problem to solve, and it's useful because sometimes you want to find the you know, where are gaps, where were no orders or what's missing. So no more there. Okay. And when I originally solved this, luckily I did not go out and look at other people's solutions. I just went out and tried to solve this myself, just with the tools in my toolbox, starting at 2012. I don't have how to solve this before that. And because I never really tried. I never really looked at this until 2012. So I just have a handful of numbers here. It's only 13 numbers, but you'll notice I've got the numbers up to 5. Then I've got a gap. So this is my first island. This is my first island where the numbers are all contiguous. You can also do this with dates. You just have to, it's just a few more little calculations you have to do. So here's my first island, and then my gap is 6 to 7. And here's my next island. And here's an island, and here's my next island. Okay, so I've got I know what I'm looking for. How do I solve this problem? So when I see some of these tricky problems, a lot of times I'll just throw a row number, which is also a window function. This one was from 2005, and what I'm really surprised when I give a presentation on windowing function, especially at a SQL Saturday, and I don't necessarily know the background of all the people in the room, but typically 25 to 50% of them have used row number before. A lot of them don't know that it's a windowing function. And to be honest, I didn't know it either until 2012. I just knew it was this new function. I didn't know it was a window function until we had these other big group of them added. So when I just add row number to this data, I want to look at that and try to find a pattern. And I see that the row number and the regular number are matching up for a while. But then all of a sudden, after the gap, they're no longer matching. Now I've got a difference of 2 here. And I still have a difference of 2, and I still have a difference of 2. And all of a sudden, I go past another gap. Now all of a sudden, I've got a difference of 3 here. And I'm like, wait a minute. Inside my island, I always have the same difference in the row number. So this will work if the numbers are unique. Now, if the row numbers are not unique, you would probably have to use dense rank, or at least maybe do get a distinct list of those. So this will work if the numbers are unique. If not, you'll have to use one of the other functions, but that's not really a big deal. So what I did next is subtract the row number so I could see that difference, and we're going to call that a difference group. So I could group together numbers 1 through 5, and I can group together numbers 8 through 11. So here's the final solution that I use. I know other people may do something different, but this is what I came up with. And once I have those groups, all I have to do is use my typical min and max. And now I have my islands, okay? And once I have my islands, I can solve for the gaps. So if I look at the data, look at the answer, my gap is 6 to 7. So what's the pattern here? I need to add 1 to 5, and I need to subtract 1 from 8, okay? Here I need to add 1 to 11, and I need to subtract 1 from 13. So now I've got this problem where I'm looking at multiple rows at the same time. If you've been paying attention, you may think, let's use lag. Maybe lag will help here. So what I did is I took my island example, and I didn't really mention, but I'm using common table expressions to separate the logic in each step. So I took this entire thing and I put it in common table expressions. So I took that outer query there, put it in this common table expression. And then in my outer query, I'm going to use lag. So for the row I'm on, I can subtract 1. But for the previous row, I need to use lag, and then I could add 1. Okay? So it makes it pretty easy to solve once you're used to using these. The only thing I don't like here is I've got this null. I don't like that. I don't want that to be in my answer. So one thing that if you've worked with window functions, you will know, if not, you may not know, is that you can't put a windowing function right into a where clause. You cannot do that. You cannot put one into the group by, okay? And that's because all the where and you can't, hopefully you would never even think of doing something like this, but you can't put it in a join condition either. I just cringe a little even thinking of doing something like that. You can't do that because those things happen before the window functions actually operate. You've got to have all of that done, the where clause and group by and from. So what you can do is separate the logic out again. So I can take this entire solution and then put it in, here I've got my gap solution, also in a common table expression. So I'm just kind of lining this logic up. And this is where I really like common table expressions because I can easily see what's going on. And sometimes for customers, I've gone in and said, you know, put a comment right here to let them know what's going on. Again, common table expressions don't always hold up performance-wise, but again, it's another tool in the toolbox. Use it when it makes sense. So all I have to do here is figure out, here's the column name of my window function expression, or my field name, I guess, and just filter it in this outer query. So now when I run this, I get the answer I'm looking for. So any questions at this point?
There are no questions.
No questions. I'm either doing a really good job or I'm doing a terrible job, one or the other.
I think it's the first.
Okay, good. And you got the recording so everybody could just go back and look at how I did things if they didn't quite keep up with it. So starting in, yeah, so there's a bunch of other functions. I might go ahead and add them to this talk. I kind of mentioned them. It seems like 2012 was such a big year. And you've got things like some convenience things like the plus equal that you can do, or let me just go back, and since I've got 10 minutes, maybe I don't have it. But things like drop table if exist, things like that are just real handy. There's a lot of cool things out there that can save you some time. Typing doesn't make a difference in how fast the query runs, but can save you some typing. So in 2017 and 2019, Microsoft added some features to the optimizer that can make things run faster. So I'm going to look at a few of these. I'm not going to cover the whole thing. And in fact, covering the whole thing is an hour-long talk in itself. But I'm going to talk about a few of them. And the beauty of these is that except for this one approximate count distinct, you don't have to make any changes to code. They just work once you upgrade to 2017 or 2019. Now, a few of them do require Enterprise Edition, but not all. Typically, if they've got anything to do, what I've found, and hopefully, I'm right on this, is that they have anything to do with the word batch. Those are the ones that require Enterprise Edition. So like the memory grant feedback, adaptive joins, and batch mode on row store. Unfortunately, I think batch mode on row store and adaptive joins are my two favorites. So let's take a look at those.
While you open it, I was so happy first time I saw the adaptive join in the query in an execution plan. I was like, I got one, yeah.
It is amazing. And right now it's only for column store index queries. But there is a way to, there's a hack you can do. I don't really cover the hack in this, but yeah, it is just, if they would add that to row store, and we can only hope that they will in the next version of SQL Server, and make that standard edition, that would solve millions of problems. Millions.
Yeah.
It really would. Oh my gosh. All right. So the way to turn these features on and off, the big way to do it is by just changing the compatibility level of the database. Okay, so that's one way you can turn them on or off. So I'm going to start with this off. And here's one of those I mentioned, drop table if exist. Yeah, love that. And I'm using add a mechanics table again, and I'm tossing the results into a temp table. And what am I doing here? This one is the I can't remember which one this is. I didn't have it. I'll just follow the results here. Oh, this one is the so let's say that we've got a formula that we use quite a bit. In this case, I'm figuring out this markup, and it runs really well, you know, and it works. You know, I've got calculating this markup. The numbers in that table don't make much sense, but I just want to show that there's just a formula. So let's say you're using this formula all over the place, and you want to create a function so that you can have code reuse, and if you want to in the future, you know, change that formula, you can change it in one place. That makes sense, right? So if we're using 2012 and we just add that formula, or not formula, but add that function instead of my formula, so all of a sudden I've got these problems. Instead of it running fast, it's going to take a long time to run. It's already, I'm going to let it go 10 seconds, then I'm going to kill it. That's long enough. So all of a sudden, even though it's the same formula, just by adding that UDF, I've killed the performance. But if I upgrade to SQL Server 2019, and this is the same code as the previous example, the only difference is that I've upgraded to 2019, it runs really fast, about a second. And I can see that it worked. So, but this is not going to work on every scalar UDF. This is called scalar UDF inlining. It is not going to work all the time. Go out and look at the documentation, because the list of things that it won't work on is like that long. Even if you have a get date in your function, if you have a while loop in your function, if you have a table variable in your function, a lot of reasons it won't work. You can have if, you can have a query, but there's a lot of reasons that it won't work. Where it does work, it's amazing. So I'm hoping that in the future, Microsoft expands or spans the places it works and decreases that list. Okay, here's, let's see, I have time. Batch mode on row store. So what's batch mode mean? Column store indexes were introduced, again, I'm thinking it's around 2012, and I just can't keep all this straight. And in order for column store indexes, part of the power of them is that they can break the data down into smaller pieces. The data is organized by columns instead of rows, if that makes sense. That'd be a whole nother talking about column store. But this was a way to make aggregate queries run faster if there was a column store index involved with the query. So starting in 2012, Microsoft added this to row store as well in certain situations. And it does decrease the amount of CPU, but I found a place where it really, really helps. If I just have a regular aggregate, I haven't seen as much of a difference. But if I have this thing called a window aggregate, this one does not have an order by. It's similar to that thing I showed with the running total. But this does not have an order by. This came out in 2005, and the problem with this particular code is that it doesn't scale well. This is the biggest problem with windowing functions. This one type called window aggregate, they do not scale very well. So if I run this, am I actually going to run this? I don't know if it's going to, how long it's going to take. Might take too long. No, it took 4 seconds. Okay, so it took 4 seconds. And the window aggregate is getting a count for that product. So that's why I'm doing that. I've got that. So if I switch to a different product ID, here's one, I've got a different product or different count. All right, so I'm going to do this just to make sure we've got a level playing field. I'm going to run the same query again, and except now I'm running it in 2019, and it should run much faster. It took 1 second, and I have, or 2 seconds. I have done timings on this where I have, you know, tried a lot of different ways. If you ever see my window function performance session, I have the charts and graphs that show the difference on the different methods. So this is really amazing, really, really amazing. Let's skip that one. I want to go to, do I have it? I might have to bring up another, because that adaptive join is really cool. I'm going to bring up another thing from past 2020, adaptive join, since we talked about that one. Okay, so this one I'm going to use Wide World Importers DW, and I am kind of stealing the query from Microsoft, except when I tried it, it didn't give me the same results, so I had to delete some data from one of them to get a big discrepancy. For some reason, and it may have changed. This has, you know, been a while since I came up with this demo. So I'm going to create a stored procedure. And one of these tables, the fact order table, is a column store index. So this does require a column store index. And let me turn that on. And I'm going to set compatibility level to 2016 because this is a 2017. Whoops, a 2017 feature. I'm going to do that just to make sure I don't have anything in the procedure cache. If I run this first one, I get back around 200 rows, 206 rows. And if I look at the execution plan, I can see that it did a clustered index scan. Then it applied the filter, and it did a hash match. So for that particular parameter, that is what it needs. That's the correct plan. If I do it with 78, I only get 5 rows back, but I get the exact same plan. Okay, we all know about this. That's parameter sniffing, right? Sometimes it is helpful, sometimes it's not. In this case, it's not. And I can show you that by running this other, running these in the opposite direction. So if I run 78 first, I get my 5 rows, and I get a very, very different plan. In this case, I have a clustered index seek because the predicate was pushed into this. That's the right way to say it. The predicate was pushed earlier. It's a clustered index seek, and then it's a nested loop. This is the proper plan for a small number of rows. And when I run 360 now, remember that one's got the hash match and the filter, but now it's stuck with the plan that's good for the small number of rows. This is a problem we all see all the time. So now if I set the compatibility level to 2017, and I'm going to free the cache again just to make sure, this time when I run 78, I see something very different. What in the world's going on here? I get this thing called an adaptive join. If I mouse over, I can see that it's got an estimated join type and an actual join type. So for this small number of rows, I want the nested loop. And what's really odd is that I see that path coming in for the large number of rows, but it wasn't used. And here's the path that I would expect for the small number of rows. So that's pretty cool. Let's see what happens if I run 360. I run 360. Again, I get the same plan with this adaptive join, but this time, even though my estimated join type was nested loop, I actually have the hash match that I know I need for that large number of rows. And when I look down here, I can see that it ignored this one, and the path that the data went down was the clustered index scan with the later applied filter, just like we need for that. So this is what we're so excited about, except that right now you need a column store index and it's Enterprise Edition. So we can just expand that, Microsoft. We will be so happy. So it looks like I have a bunch of resources. I'm not going to go through all these. I'll send the slides to the organizer, or you can contact me as well. And I just wanted to bring up one more thing, is that Redgate has a survey right now about DevOps. Whether or not you're using DevOps in your organization, please go out and fill out the survey. We are donating money to the World Health Organization for every person or every submission. And then the people that submit also are eligible to win, I believe it's $500 Amazon gift card. Might be wrong on the amount, so don't quote me on that. So that's all I've got. Are there any additional questions or any questions at all?
There are no questions. There is Patrick saying good job, and I agree.
Thank you.
And to everyone still on the call and listening, please take the survey. It's a good thing.
Yeah, it's going to help us understand what's going on, and this is like a new area to get database in DevOps. It's a new way of thinking, so you can be a part of how that goes.
Yeah, and the thing is, if I know a lot of people who use Redgate tools, I do myself, and some of them I don't know how. For example, SQL prompt. I don't know how I lived before I got SQL prompt. So
yeah.
But there are some other tools. In a previous engagement I had, we used this. What's it called? It's a tool for deploying database scripts, and I don't remember the name of it. Anyway, it's also a Redgate tool. But if you like the Redgate tooling, then take this survey so that Redgate can create the right tools for it.
Even if you don't like Redgate tools, do it. Hopefully you do, but even if you're not a customer of ours, go out and take the survey. So, all right, I will send you the materials, and if there's nothing else, I guess I'm done.
Yeah, you did an awesome job. Thank you so much for coming, and thank you for doing it kind of in the middle of the night.
It's morning. It's not really middle of. I had to get up at 4, but that's not bad. That's not bad.
To me, when I used to wake up really early, if the clock was set to something before 5, I would consider it still night when I woke up. It's
dark out still, yeah. It's still dark.
So. I live in Sweden, so for us it's dark till 9 in the morning, and then it's dark again at 3 o'clock. So it's terrible.
I had enough here, but yeah, I don't think I could handle that.
I had my cousin moved up to the very north of Sweden, so that's another, I don't know, 2,000 kilometers or something. He don't see the sun for a month every year at all. There is no sunrise. On the
Yeah.
other hand, the sun doesn't set for a month in the summer, so it's a cool thing, but I don't think I could handle it.
I'd have to leave. I'd have to leave when it was dark all the time.
Yeah, and I mean, as a bonus, he also gets snow. It's snow from basically end of September till April.
Nope, don't like that either.
Not my kind of weather, no.
No. I would
Anyway,
just be summer all the time.
I'm gonna jump into work meetings. So thank you so much for joining. I think the recording will be edited and put out on YouTube probably later tonight. If not, they will be tomorrow. And I will tweet and mention you so you know where it is.
Awesome. All right. Thanks a lot. Thanks for inviting me.
Thank you. See you. Hope to see you in a physical in-person event at some time in the future. But for now and for another at least half a year, this is what we have.
Yep.
So,
all right. Bye.
have a good day.